Hey guys, welcome again to the Maths Club. And in this particular video, we'll be looking at change of subjects of a formula or a relation. You're given a formula, you want to make maybe the x of the formula or the y of the formula and things like that. So to put it simply, it involves altering an equation so that a different variable becomes the focus or subject of the equation. And it is essential because it has application in various fields such as mathematics, physics, and engineering. So let's go straight to solving questions. This is more of a solving question type of concept. So the first example says that we should make f distribute the formula in the relation v is equal to u plus ft. This is taken from 2005. I want you to actually pause the video and try this out yourself. Welcome back. Let's solve it together. So we have this. The first thing I want to do is that we want to make anything that is joined with the f to stand alone. So now we have u, which is u plus ft. So we want to make this ft stand alone. So I'll just say ft is equal to, I'll take over this u to the other side. That will be v minus u. And because I want to make the f stand alone, this is like f times t. To make f stand alone, I will do what? I will divide both sides by t. So this t will cancel this t. Therefore, our f will just be equal to v minus u all over t. So now let's see if our answer is correct. Great. So our f is equal to v minus u all over t. Next example says that if p is equal to 3 over 5 square root of q over r, express q in terms of p and r. This is from 2008. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So like always, we want to isolate anything that has to do with q. So this place here, to make the square root of q over r stand alone, I divide both sides by 3 over 5. So that will be p divided by 3 over 5 is equal to 3 over 5 square root of q over r divided by 3 over 5. So this is like saying p times 5 over 3 is equal to 3 over 5 square root of q over r times 5 over 3. So 3 will cancel 3, 5 will cancel 5. So what we have here is 5p all over 3 is equal to square root of q over r. So now this is another dilemma. We want to make use of the formula, but q is inside the square roots. So how do I remove that square root? So I'll just take the square of both sides, and that will be 5p over 3 all squared is equal to square root of q over r all squared. So 5 squared is 25. P squared is p squared. All over 3 squared is 9 is equal to, because of this square now, this square root to go. So that is q over r. So if I wanted to make this q stand alone, I would just multiply both sides by r because this is q over r. So if I multiply this place by r and I multiply this place by r, it will go. So that would be 25p squared all over 9r is equal to q over r times r. This will cancel this. So I could say q is equal to 25p square r all over this 9. So all over 9. So this is basically our answer. If you got this, well done to you. Let's see if we're correct. Great. So 25p square r all over 9. The next example says that we should make q resolve the formula if p is equal to m over 5 open brackets x plus q plus 1. This is from JAMB 1989. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. So the first thing is that this guy is here, is multiplication that is joining, but there's one that is addition. So I'll just carry the addition to that side. That will be p minus 1 is equal to m over 5 x plus q, right? Then look at the q is inside this x plus q, which is multiplying this m over 5. So let me first remove this m over 5. How will I remove it? I'll divide both sides by m over 5. So that is p minus 1 multiplying m over 5 is equal to m over 5. Oh, sorry, not multiplying, dividing m over 5 open brackets x plus q divided by m over 5. So this is p minus 1 multiplying 5 over m is equal to m over 5 open brackets x plus q multiplying 5 over m. So 5 will cancel 5, m will cancel m. We have this now. So we have p minus 1, and let me just say 5p minus 1 all over m is equal to x plus q. So to make this q stand alone, which is what we want to find, we'll just take over this x to the other side. So we'll say q is equal to 5, let me open this bracket. So 5p minus 5 all over m, then minus x. I just swapped positions and opened brackets. So I could make maybe the LCM. So m in m, this is 5p minus 5. So this all over 1. M in 1 is m. M times x is minus mx. So this is our formula for q. So they might have rearranged it in another way. Maybe in material and say maybe 5p minus mx minus 5 all over m. It's still the same thing. It's just rearrangement. So let's see if our answer is correct. Great. So we have 5p minus mx minus 5 all over m as our answer. If you got this, well done to you. Next question says that if GT minus k minus w is equal to 0, make G the sort of formula. And this is taken from JAMB 2015. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we have GT minus k minus w is equal to 0. First things first, that anything does not have to do with g, take it to the other side. So that is GT is equal to minus k will turn to k minus w will turn to plus w. Then I'll divide both sides by t. So t will cancel t. Then our g is just equal to k plus w all over t. If you got this, well done to you. But let's see if our answer is correct. Great. So k plus w all over t. Next example says that we should make p the sort of the relation q is equal to 3p over r plus s over 2. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So as always, we'll take anything that does not have to do with p to the other side. This s over 2 does not have anything to do with p. So that will be q minus s over 2 is equal to 3p all over r. So let's do the LCM. So 2 in 1 is 2 times q. That was 2q minus 2 in 2 is 1 times s. That is s is equal to 3p all over r. So let me just cross multiply. So that would be 2q minus s multiplying r is equal to 3p times 2. So that would be 2q minus s r is equal to 6p. So if I want to make p of the formula, I just need to divide both sides by 6 and I'll be good. So 6 will cancel 6. What will have will be p is equal to, don't let me open up this bracket with this r, since there are only two things and the r will be shared to all of them. So let me just leave it outside. So that's 2q minus s r all over 6. So this should be our answer. Let's see if we're correct. Great. So we have r open bracket 2q minus s all over 6. Example 6 says that we should make t the formula where k is equal to m square root of t minus p all over r. This is taken from WAEC 2000. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we have k is equal to m square root of t minus p all over r. First things first, I want to isolate this square root because our t is inside it, so I can divide both sides by m. So I'll say dividing both sides by m, but I'm not writing it. So we have k over m is equal to square root of t minus p all over r. So if you want to make this square root to go, what do? Right, so we take the square of both sides. That will be k over m all squared is equal to square root of t minus p all over r all squared. So that will be k squared over m squared is equal to t minus p all over r. So if I cross multiply, this would be k square r is equal to m squared open bracket t minus p, right? Then I can divide both sides by m squared. You know, there's no one way of solving this. You can solve it in any way as long as you are following a particular procedure and you know what you're doing. So this k square r all over m is equal to t minus p. So because I want to make the t stand alone, I'll take the minus p to the other side. That will be t is equal to k square r all over m plus p, right? So let's just make the answer look a bit more organized. So m in m is 1 times k square r is k square r plus m in 1 is m times p, that is m. So I made a mistake somewhere here. I forgot the square here. So this is meant to be m squared, right? So this will be m squared, and that means our LCM will be m squared. So m squared, the m squared will be 1 times k square r will be k square r, and m squared, the 1 is m squared times p, that will be m squared. So our answer is k square r plus m square p all over m squared. So let's see if our answer is correct. So k square r plus maybe pm squared and p squared, the same thing, all over m squared. Example 7 says that we should make x to be the formula for v is equal to k all over square root of t minus s. This take from WAEC 1998. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. So this is v is equal to k over square root of t minus s. Right, so if we cross multiply, we're going to have v times square root of t minus s is equal to k. And if I divide both sides by v, so that will be v will cancel v, then we'll have square root of t minus s is equal to k over v. Right? So the next thing to do is to take the square of both sides to remove the square roots. So this will be t minus s is equal to k squared all over v squared. Right? And because I want to make s of the formula, this is minus s is equal to k squared all over v squared minus t. So this is all over v squared. V squared and v squared is 1 times k squared is k squared minus this is like saying t over 1. V squared in 1 is v squared times t, that is v squared t. So this is minus s. So I have to divide both sides by minus. So let me just say times minus 1. It's the same thing. So s will now be equal to, what will just happen is that the one that is negative at the top will become positive, and the one that is positive at the top will become negative. So I can also swap their positions. Or let me take it step by step. So that will be minus k squared plus v squared t all over v squared. And I can make the plus come first. That is s is equal to v squared t minus k squared all over v squared. So we have v squared t minus k squared all over v squared. This should be our answer. Let's see if we're correct. Okay, so they did it like this. Let's try to reward our answer and see if we can get this. So this, like saying, is equal to v squared t all over v squared minus k squared all over v squared. So v squared will cancel v squared, right? So this is like saying s is equal to t minus k squared all over v squared. So let's see now. Great. So s is equal to t minus k squared all over v squared. Great. Next example says that we should make q the sort of relation for t is equal to square root of pq all over r minus r squared q. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So taking the square root of both sides will be t squared is equal to square root of pq all over r minus r squared q all squared. So this t squared is equal to the square root to be over. So that will be pq over r minus r squared q, right? We want to make q sub the formula. So q is present here, q is present. I can factor out that q. That is t squared is equal to, if I factor out q from this will be q open brackets, q, this divided by q, this will give me p over r, minus this divided by q, this will give me r squared. So all I need to do is just divide both sides by p over r minus r squared. Wow. So all over p over r minus r squared. So this will cancel this. So this is like saying q is equal to t squared all over, let me do the bottom, this bottom guy. So the LCM of this bottom guy is r, right? R in r is 1, 1 times p is p, minus, so this is like over 1. R in 1 is r, r times r squared is r cube. So this is what we have. So I can now say q is equal to t squared divided by, in brackets, p minus r cube all over r. So I can say this is equal to t squared times r all over p minus r cube. And this will now be equal to q is equal to t squared r all over p minus r cube. So this is basically the answer. This might not be the same approach that you use, but just follow through on whatever approach that you choose to use. Let's see if our answer is correct. Great. So we have rt squared or t squared r, same thing, all over p minus r cube. So the next question says that if p is equal to square root of qr, open brackets, 1 plus 3t all over r, we should make r the sum of the formula. This taken from WAEC 2003. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. So the first thing I want to do is take the square of both sides. So that will be p squared is equal to qr, open brackets, 1 plus 3t all over r. So after we do that, let me first make whatever is not r go away. So if I divide both sides by q, what I will have is p squared all over q. Q will cancel q is equal to, and if I expand the bracket, this r times 1 will give me r plus 3t all over r multiplying r. So r will cancel r. So what I have will be p squared all over q is equal to r plus 3t. So I can just take this 3t to the other side. So that will be r is equal to p squared all over q minus 3t. So I could do some clean up. So q in q is 1 times p squared. That will be p squared minus, let's say, over 1. Q in 1 is q times c. That will be 3cq. So our r is equal to p squared minus 3cq all over q. Let's see if our answer is correct. Great. So p squared minus 3qt all over q. Whether you say 3qt or 3tq, that's the saying the same thing. Example 10 says that we should make use of the formula where E is equal to m over 2g open brackets v squared minus u squared. This is taken from WAEC 2014. So I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So the idea of solving a lot of questions and pausing the video is that the more questions you solve about something, the more confidence will be in it. Right? You know, in secondary school, one of the things that we do is that they'll just give us like 2 examples and then they'll give us a very conc question on the day of test or exam. But the more you solve questions, different questions, you just start seeing patterns in all these things. So we have E is equal to m over 2g open brackets v squared minus u squared, right? We want to make use of the formula. So the first thing is that we can maybe cross multiply. So if I cross multiply this will be E times 2g is equal to m open brackets v squared minus u squared, right? So this is 2eg is equal to m open brackets v squared minus u squared. So the next thing is that we want to make use of the formula, so I can divide both sides by m. So this will cancel this. What will be left to be v squared minus u squared is equal to 2eg all over m. Because we want to make use of the formula, I will take whatever is not used to the other side. That will be minus u squared is equal to 2eg all over m. Then this will be minus v squared. So I can divide both sides by minus. Right, so this will be u squared is equal to, when you divide both sides by minus, what was plus will become minus, what was minus will become plus. So that will be minus 2eg all over m, then plus v squared. So I can reorder it and say u squared is equal to v squared minus 2eg all over m. You always want the positive to always come first. Because I want to make m stand alone, what will I do? So I'll take the square root of both sides. So by the time I take square root of both sides, it will remove the square here. So that means square root of u squared is equal to square root of v squared minus 2eg all over m. So by the time we cancel, this will be u is equal to square root of v squared minus 2eg all over m. It depends on how they want to put it. They could have put it and said square root of, they could clean up and say m. So let's say in m in 1 is m times v squared. That will be mv squared minus m in m is 1 times 2eg. That will be 2eg. So any of these answers will actually fly depending on how they want to express it. Let's see if our answer is correct. Great. So we have u is equal to square root of v squared minus 2eg all over m. Hold on to you if you got it. Example 11 says that we should make r the sum of the formula from the equation s is equal to square root of 2r plus t all over 2rt. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So the first is that I can square both sides. So that will be s squared is equal to 2r plus t all over 2rt. Right? Then the next thing that I will maybe want to do is to cross multiply. So that is s squared times 2rt, 2r plus t. So this is 2r s squared t is equal to 2r plus t. Right? I want to make r of the formula. So anything that has to do with r, I'll take it to one side. So that will be 2r s squared t minus 2r is equal to t. Then I can factor out the r. So if I factor out, if I divide this by r, this will give me 2s squared t minus, if I divide this by r, this will give me minus 2 is equal to t. So therefore our r is equal to, I can divide both sides by 2s squared t minus 2. So that will be t all over 2s squared t minus 2. By the time we solved all of this and we divided, we had r is equal to t all over 2s squared t all over minus 2. Let's see if our answer is correct. So r is equal to t all over 2s squared t minus 2. Well done to you if you got it. Example 12 says that we should make r the the formula where x over r plus a is equal to a over r. This is from JAMB 2002. I want you to pause the video and try this out. Welcome back. Let's solve it together. So we have x over r plus a is equal to a over r. We want to make r solve the formula, but first let's cross multiply. So that will be xr is equal to a open brackets r plus a. which seems like saying AR plus A squared. So XR, because once we make R sub the formula, we'll take everything that has to do with R to the other side. That will be XR minus AR is equal to A squared. So I can factor out R and say XR divided by R is X minus AR divided by R is A is equal to A squared. So R is equal to A squared all over X minus A. Simple and short. Let's see if the answer is correct. Great. So our R is equal to A squared all over X minus A. Now the last question, example 13, says that given that S is equal to K square root of M squared plus N squared, make M the sum of the formula. Then it now says if S is equal to 12.2, K is equal to 0.02, and N is equal to 1.1, find, correct to the nearest whole number, the positive value of M. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So to make K sum of the formula, we can just say we have S is equal to K square root of M squared plus N squared. So if I divide both sides by K, that is S over K is equal to, this one will have cancelled this one, so this is square root of M squared plus N squared. Now if I square both sides, this will give me S squared all over K squared, right? So this is equal to, this square root will have been removed, so this is M squared plus N squared. Now that we know that I want to make M sum of the formula, so I take out everything that is not M squared, so that will be M squared is equal to S squared all over K squared minus N squared, taking this one to the other side, right? And to make the M stand alone, I have to take the square roots of both sides. That will be square root of M squared is equal to square root of S squared all over K squared minus N squared. This is M is equal to square root of S squared all over K squared minus N squared. So we could simplify this also and say this is like saying square root of all over K squared. K squared and K squared is 1 times S squared. This is S squared minus, this is like saying N squared over 1. K squared in 1 is K squared times N squared. That would be K squared N squared. So these are value for M. Now that I know these are value for M, we are told that, what were we told in the question? S is equal to 12.2, K is equal to 0.02, and N is equal to 1.1. We're told to find M and correct it to the nearest whole number. So that means our M will be equal to square root of, so this is 12.2 squared minus 0.02 squared times 1.1 squared all over 0.02 squared. 12.2 squared minus 0.02 squared times 1.1 squared. Then I would equal it, so add 144 square root of 148.839516. Let me just write everything down so that I don't have any approximation issue. So I'll now divide this by 0.02, or if I do 0.02 squared, what does that give me? It gives me 4 times 10 raised to the power of minus 4. So if I divide this guy, so I add 148.839516, and I have 4 exponential minus 4, and I find the square roots. When I found the square root of everything, it gave me 609.999. But then it said that we should wrap it up to the nearest whole number. This is 9. It will add 1 to it, so that will be approximately 610. So our M is approximately 610 to the nearest whole number. Let's see if we're correct. Great. So we can see so plus or minus raised to the power of half is something like saying square roots. So it's like saying square root of S squared minus N squared K squared all over K squared, and our M is approximately 610. Because I said you should have find the positive value of M. You know, when you take the square roots, there's possibility that you have a plus or a minus, right? Because minus 2 times minus 2 is 4, and 2 times 2 is 4. Because minus times minus is plus, so you have to take note of the negative portion or the positive portion. But the question is that we should find the positive value of M. So that is it about change of a subject of formula. It's just understanding the concept and the principles behind it and knowing how to manipulate algebra. If you found this video useful, like the video, subscribe to our channel, hit the notification bell so that every time we post something, you are always updated. And then if you know people that this channel can help, please spread the word. The channel has been growing very well and it's really encouraging. So I'll see you guys in the next video.